Hello Year 12, I'm going to talk through the last two questions on your recent assessment. So those two mechanics questions, so really quite lengthy, 8 marks, and then particularly that monstrous 16 marks. If you were doing it in normal circumstances, not that tricky, but as you're rushing towards the end of the paper, it is easy to lose marks. So firstly, this question 10, we have a velocity time graph. Two distinct parts. So the situation, we've got this car travelling at a speed of 18 metres per second from when we're starting, considering so when time is 0. We are decelerating. It's not constant, of course, because we don't have a line with constant gradient. So for that part of the graph, it's part of a quadratic, this quadratic here. We don't know the equation. The first part of the question, we need to essentially work out the equation for this part. Then when the car reaches 5 seconds and a speed velocity of 9, it's a constant speed, so we're not accelerating for this bit here. So presumably that's the part where it's travelling through the residential area. So what we need to do is we need to somehow work out these values of P, Q and R. So we want some reference points. And we know 2 points on this curve that we know 2 things. So I know that at that point there, the time is 0 and the velocity is 18. So what I can do is I can take those 2 values and put them into our equation. I know that when the velocity is 18, substituting the left-hand side, that is equal to P multiplied by the time squared, so it's going to be 0 squared, plus Q multiplied by the time 0 plus R. Both of these 2 terms 0, so that leaves me with relatively nice R of 18. Now, if I look at this point, so this is the other point that I know both the time and the velocity for. So I know that when the time is equal to 9, the time is 5, the velocity is equal to 9. Substituting those in then, I have that 9 is equal to P multiplied by 5 squared plus Q multiplied by 5 plus R, but of course I've just worked out that R is 18, so I'm going to put that in. Simplifying that, 25P plus 5Q plus 18, and I'm just going to rewrite that by having the 2 algebraic terms, so the P and the Q term on the left-hand side, and so it'll be 9, take away the 18, 9 minus 9. Here then, so I've done all that I can immediately do. I've worked out the value of R, but annoyingly, I haven't found P and Q. I've got an equation with a P and a Q in it. Now, hopefully, you recognise that as being 1/2 of a simultaneous equation. We need one further equation so we can work out P and Q. And if you think about it, we started off with 3 unknowns. To work out 3 unknowns, you need 3 equations. To work out 2 unknowns, you need 2 equations. So there's one more piece of information that we need, that we've been given here. We certainly don't have another point within there. Of course, we can't use anything on this straight line because it's no longer that quadratic. This part of the curve only applies to the times between 0 and 5. So there's something else here. I know that when the acceleration of the car is 0, t is equal to 5. So it's like another condition here, isn't it? So this is telling me that when time is equal to 5 seconds, the acceleration is 0. The only thing is we don't have an expression for acceleration. But this expression here, non-constant acceleration, we had ways of working out acceleration. You know that acceleration is the gradient of velocity time graph. And when you've got a curve, when you've got something, an equation in terms of t, of course, what we do is we differentiate. So given a displacement equation, we differentiate to find a velocity. given a velocity equation, we differentiate it to find the acceleration. So we know the velocity, or we know an expression for the velocity. We can then differentiate it. Differentiate that, bring the power down, reduce the power by 1. Differentiate that will just leave me to Q, and differentiate that, differentiate a constant, that just kind of vanishes. So that is an equation for my acceleration. And as I've got up here, I know that the acceleration is 0 when the time is 5. So my acceleration of 0 is equal to 2p multiplied by 5 seconds plus q. So that's going to give me 10p plus q equals 0. And there, of course, is my second equation. So together, I've got a pair of simultaneous equations. You don't get any credit whatsoever for working that out yourself. So please use the calculator. So I'm going to simultaneous, 2 unknowns. I've already got the coefficients in. So I've got 25, 5, negative 9, 10, 1 and 0. Solving that then, that gets me the value of p equal to 9 over 25. And of course you could write down the decimal equivalent, 0.36. Q is equal to negative 3.6 or negative 18/5. And of course I've got R there, but it's nice just to write it all together. There. Okay, so there's my P, my Q and my R. The next part, only 3 marks. So what I've done there was worth 5 marks. Here I've only got 3. Calculate the distance travelled by the car from t equals 2 to t equals 10. So first of all, it's 2 seconds. The first time I did this, I was thinking I was working out the whole area. So distance travelled, we know. Distance on a velocity time graph, it's the area, so I need to work out that area. This, of course, is the simple bit. It's just the area of a rectangle. This is the bit where we have to worry about a little bit more. And acceleration, we differentiate a velocity expression to work out the distance or the displacement under a curve, or when you give an equation like this, we need to do the opposite. We need to integrate. And we need to integrate with our limits of 5 and 2. So the velocity expression, of course, I know P, Q and R, so I can now write down what that is. It's going to be P, which is 9/25 multiplied by t squared, plus Q, so it'll be, because Q is negative, minus 18 over 5 times by t plus R. And I know that R, apologies, is equal to 18. Limits of 5 and 2. So if we integrate that, cubed divide by 3, that's going to be 3/25 t cubed, t squared divided by 2, so that'll be 9/5 t squared. Integrate that, 18t. And our limits are 5 and 2. You can evaluate that at 5. Apologies, I've kind of done this, got the answers already. But 3/25 times by 5 cubed minus 9/5 times by, you get the idea. And then when we evaluate that at 2, it's not quite so nice. 29.76. Subtracting those, we get 30.24. But I want to make the point. This is really quite a lengthy process. We've only got 3 marks in total for this question. And when I tell you that one of those marks is for finding that area is, of course, 5 times by 9. So you get 1 mark just for writing down, calculating 45 metres. You get 1 mark for adding that area plus that area. So you only actually get 1 mark for all of that. And of course the reason is because they are expecting you to use your calculator. And please, please do, because this is, you know, really quite a lengthy process. The decimals or the fractions make it quite complicated as well. Using a calculator, you know, saves all of that error. So of course, what we do on our calculator, if I go back to normal run mode, I need to go to option, calc. We're doing some calculus. I'm looking for an integral. This is my integral, so 9 over 25, that is 0.36. There isn't a t, so you use x, so x squared, and then the 18 over 5 is equal to 3.6, so then got minus 3.6 t, we have to use x, and then plus 18. I haven't put in my limits, so let's go back and do those limits. I can't get in there. That's annoying. So there will be a way of getting in there. There, I'm in. So 2 there, and can I go up to the upper limit? Excellent, 5. The answer, 756 over 25. Hopefully that is, yep, 30.24. Okay, so look at the number of marks. Only 3, a very small number of marks. So please use your calculator. If the question had said show detailed reasoning, if the question was worth 6 marks, then absolutely kind of do it by hand. But it won't. It won't on a mechanics paper. They're not testing whether you can integrate fairly basic functions, substitute limits. What they're doing is they're testing your understanding of whether you know that a distance, to find a distance, you integrate the velocity. So I just need to kind of finish this up. I've already kind of said what we need to do. I know that the area or the distance from 5 to 10 seconds is equal to 5 times by 9, which is 45. So total distance travelled is just going to be the sum of those two. So 30.24 plus 45. 75.24 meters. Okay, so shall we move on? Let's move on to the last question. Okay. Now, we've seen this kind of situation before, where you've had a pulley on the edge of the table, and what normally happens is you let it go, Q travels down, P travels towards the pulley. But it was just slightly unsettling that we've got something different going on here. What we know, or what we've got this force of 40 newtons there. So the horizontal force acts on this in that direction. And then P is released. So imagine, you're there pulling on P with a force of 40 newtons, and then there's somebody else who's holding P and stopping it from moving. Then that person takes their hand off, and so of course your force of 40 is going to be pulling it towards the left. So it's a little bit different from normal, just in the setup, just in the situation, but of course the forces, the equation, all happen in the same way. So what's happening to P? So I know I've got a force of 40 newtons going in that direction. I also have the tension in the string that's going to be acting in the opposite direction. And there's a further force. You've got this constant frictional force, 8 newtons. Friction always opposes the motion. In fact, it's telling you it's opposing the motion. So I know that that is going in that direction as well. It's accelerating, and of course we know that whenever we're accelerating we use F equals ma. Don't just think of it like F though, it's the resultant force in the direction of motion. That's what is equal to MA. So we've actually got three forces here. 40 is going in the direction of the motion. The tension and the 8 are both opposing the motion, so they're both going to be negative. And that's equal to the mass of A, which is 3 kilograms, times by its acceleration. So if we just tidied that up, that's going to be 32, isn't it? So I have 32 minus T is equal to 3A. And very similar to the last question, we've got two unknowns there. We are looking for a second equation, second part of the information that's going to have an equation with A and T in again. And this is a standard thing with your connected particles. So I'm going to look and see what's happening to Q. So the forces on Q, I have got the weight, so that's mg, its mass is 2, so 2g, acting downwards, and I've got the tension in the string that's acting upwards. Q is travelling upwards, so if I think about the equation resultant force in the direction of motion, T is going up, so that's what I start with. 2g going downwards, that's opposing the motion, and that is equal to the mass of Q multiplied by its acceleration. There is my second equation. It's the same T, it's the same A, so I have got two simultaneous equations which I can now solve. And I'm sure you remember that whenever you've got connected particles, adding the two equations is a really good way to solve it. You could rearrange and type it into your calculator, but there's always kind of a little bit of scope to error. It's really simple here to add them. You'll always have a negative T in one equation and a positive T in the other equation. Add together the left-hand sides, 32 minus T plus T minus 2G. The T's cancel and I'm just left with 32 minus 2G. Add these two, 5A. So of course to find the acceleration, I do 32 minus 2 times by 9.8 over 5. And if I work that out, I get an answer of 2.48 metres per second. And of course this was a show that, so because it's a show that, you need to be careful and make sure you show each of your lines of working. Okay, so that is part A. To work out part B, I think we've done the tricky bit, sorting out the situation, sorting out what was going on with this kind of odd extra force of 40, I think was the difficult bit initially. Find the tension in the string, well, I can just use one of these two equations here. Let's use that one because it's simpler to rearrange. I know that T minus 2G is equal to 2A, so T is equal to 2 multiplied by the 2.48, the value we've just found, plus 2 times by G, which is 9.8. And working that out gets you 24.56 newtons. Okay, so as I said, I think those first 7 marks, once you'd sorted out that force of 40, were fairly straightforward, because you had the time. Now, something exciting happens. When the balls have been in motion for 0.5 seconds, the string breaks. So Q is travelling upwards, Q is travelling upwards, and it's accelerating upwards with an acceleration of 2.48 metres per second. Sorry, that should be squared, of course. So it's travelling upwards, and then after half a second, the string breaks. So it's still going to be going upwards because it's still got that positive velocity, but of course it's going to be slowing down. So it's going to be moving upwards, but it's going to be slowing down because it will be accelerating freely under gravity. So it will be slowing down, the acceleration of negative 9.8. So it's going to get to a certain point and then it will come back down. We need to work out the time at which it hits the floor. So the first thing we need the speed of Q when the string breaks. Now this is where directions are crucial. I know that my acceleration is equal to 2.48. I know that the time is equal to 0.5. I know that initially the speed of u was equal to 0. I need to find v. So looking at these four options here, there's one equation that involves vu, a and t, and that's v is equal to u plus at. So v is u 0 plus 2.48 multiplied by 0.5. 1.24 meters per second. Okay, so I also need to work out how far Q travelled in that time. So I need to work out now how far Q is off the floor for when I consider this the new acceleration, so the new part of the motion. So I also need the distance that Q travels in that 0.5 seconds. So based on these two bits of information, this time I need the distance, so I need S. So I need an equation with S, U, A and T. So I'm going to use S equals UT plus a half AT squared. S is U, which is 0 multiplied by T, 0.5, plus a half multiplied by A, 2.48 multiplied by 0.5 squared. That's 0, so if I work out 0.5 times by 2.48 times by 0.5 squared, 0.31 meters. So when the string breaks then, I've got this situation. So Q is travelling upwards. I know that its initial speed is equal to 1.24 meters per second. Of course, I've got it labelled as v there, but the final speed for that section of the journey is the same as the initial speed for this part of the journey. The distance from there to the floor, well, I had the initial 2 meters, so it was 2 meters above the floor. It's now moved up that extra 0.31. So I know that the distance is 2.31 meters. I then know that the acceleration is equal to 9.8 meters per second squared. But we need to be careful and we need to think about directions. Okay, so directions is always where people go wrong on these problems. So I need, was it the time? No, the speed. So I need to work out the speed. But for this section, upwards being positive, I have that u is equal to 1.24. The acceleration, of course, is acting in the opposite direction. So the acceleration is negative 9.8. And the other thing is, because it's going down, if we take that as that starting level, it's travelling downwards, so it's also a negative distance. It's travelling up, it's going up a little bit, and it's coming down a little bit, so that displacement will cancel out. So you don't need to find how far it is up to the greatest height. The displacement there cancels, so the overall displacement from there all the way up and all the way down is negative 2.31. And then we need to find the V. or is it T? Oh, the time, we need time first, and then I think we need V afterwards. So an equation connecting all of these things, it's going to be S equals ut plus a half at squared. So S negative 2.31 is equal to U 1.24 multiplied by T plus a half times by negative 9.8 times by T squared. I've got a quadratic, that's going to be negative 4.9. I'm going to put it on the left hand side to make it positive. That will be negative 1.24t when I put it on the left, and then that's negative 2.31. Again, please use your calculator for solving this. Menu A, polynomial, I have got, are these the right values? Yes, they are. 4.9, negative 1.24 and negative 2.31. Solving that gets me two values of t, 0.8247. The other one, I'm not going to want that because that is a negative time. So that is my time. Now we are looking at the speed. So to find the speed, I can of course use that time, but it's often safer to go back to the things that were given earlier, just in case I did something wrong there. So I've got that U is equal to 1.24, A is negative 9.8, S is minus 2.31, and I need V. The equation connecting all of these, V squared is U squared plus 2AS. V squared, U squared, 1.24 squared plus 2 times by negative 9.8 times by negative 2.31. 1.24 squared plus 2 times by negative 9.8 times by negative 2.31. That gets me that V squared is 46.8136. Square rooting that hopefully gives me the right answer. 6.84, 6.842. Did it give me a 6.842 meters per second? And I think I might need to write that to 2 decimal places or 3 significant figures. I think that was the standard degree of accuracy that it asked for at the start of the paper. Okay, and then we've just got a couple more little bits. It says, write down the magnitude of the normal force reacting on Q when Q has come to rest on the floor. So when Q has come to rest on the floor, there it is, sitting there. The only force that's acting is its weight. Normal reaction force, because it's an equilibrium, is just going to balance that. So R is just simply equal to 2G. So it was just 1 mark. It's just wanting you to work out 2 times by 9.8, which is 19.6. And the last of these state 1 improvement that could be made to the model, well, I guess if you kind of pick up on, you know, a few of the things written here, the balls are modelled as particles. Okay, so you could say you're modelling them as something larger. The pulley is smooth was an assumption it made there. So one of your assumptions could be, or one of your improvements could be, to take some friction on the pulley. Other alternatives, you could have said that instead of having G as being 9.8, we could have a more accurate value of G. Up here somewhere it said a constant force, a constant frictional force of magnitude 8. That of course is an assumption, that's a modelling assumption. We could include a variable resistive force. So there are a number of things there, just wanted one sensible thing.